Hi, everybody. I thought I would work through some of these isotope problems with you. I'm imagining that this is one of the more difficult, types of problems that we've been working on. I think most of what we've done in this unit, chapters 3 and 4, has been pretty simple, but this is where maybe some of you are getting tripped up. So just want to go through a couple of these really quickly. So here we've got a table. We've got we've got an element, an imaginary element named element Q, and there are 4 isotopes of Q. Remember, isotopes are atoms of a certain element that have a different number of neutrons. Remember, all atoms of a certain element would all have the same number of protons, but not necessarily the same number of neutrons. Now, for isotope Q, we can see that the abundance of the second isotope is the most abundant. Okay, so the answer to number 1 here, what's the most common isotope of Q? It's going to be isotope number 2, or in other words, the isotope with a mass number of 39. Okay. There are 2 ways of writing this symbol for this isotope. I could make a superscript of 39 in the top left corner of the symbol Q, or I could say Q with a dash in 39. This is probably going to be the most useful way to write the symbol for an isotope, though. I would call this the isotopic symbol for Q39. All right, now in this next question, what do you predict the average atomic mass of Q to be? I'm going to assume or predict that this isotope 39, since it's the most abundant isotope, the weighted average should really come out to be pretty close to 39 or so. Okay. The weighted average for the atomic mass for element Q should be around 39 or so. Why is that? Because Q39 represents about 80% of all of the isotopes of element Q. So now we're going to calculate the average atomic mass for Q. All right. Remember, the average is a weighted average. It's not a straight average. We're not going to add all of these up and divide by 4, okay? We're going to find the weighted average in the following way. Okay, so I set up the math here. And now, ideally, guys, now this is a really important point. Please listen carefully to this. Since we're not actually given the atomic masses for these isotopes, we're going to go with the next best thing, okay? The next best thing that we're given is the mass number, okay? Truly, the mass number is not the atomic mass of these isotopes, but it's the best information given, so we're going to go with that. If you were actually given the atomic masses in AMU for each of these isotopes, you would use that. So always use the best information given. In this case, 38 and 39 and 40 and 41 are given, but those are only the mass numbers. Those are not the real atomic mass. Later on, we'll try a problem where we're actually given atomic mass. So what I'm going to do now is just do the math, and I'll be right back. Okay, so I did the math, and I got 3.675 and 34.360 and so on. Now what I'm going to do is add these numbers together, and I will get the weighted average for element Q. Okay, actually I realized I made a mistake on this number, so I changed it. Adding these together now, I got 39.023 AMU. This is the weighted average for all of the isotopes for element Q. Now, on the periodic table, the element that is closest to this number looks to me like potassium. On my periodic table, potassium is 39.098. It's not perfect, it's not dead on, but I would say this is potassium. Okay. It's the closest element with that atomic mass. Okay, so let's try another one just for fun. Are you ready for some fun? Here we go. Now, guys, listen. Remember when I said if you're given the atomic mass, use the atomic mass. Notice how we are given the atomic mass number, 40, but the actual mass is 40.3 AMU. So we're going to use that mass. And for 42, the atomic mass is 41.9. For 44, the mass is 44.4 AMU. Now, just looking at this, I would assume that our weighted average is going to be somewhere just above 40, probably less than 41. We'll see what happens, okay? So I'm going to set this up, and then I'll be right back. All right, so I set it up. You can see how I set it up. I got a weighted average of 40.584. So it matches my prediction. I figured it would be a little bit more than 40, probably less than 41, and there we are. You might be wondering, how am I supposed to round? I'll tell you what, it doesn't really matter. You could always use significant figures, and if I did go with significant figures, then my answers here would be to 3 significant figures, right? I broke the rules on that, and who cares, you know? So here is my answer. Now, the next one, let's do this one also. All right, now in this problem, we've got 2 isotopes of lithium. One has an atomic mass of 6.015, the other one has 7.016. The relative abundance of the heavier isotope is going to be that 7, okay, is 92.58. Now, you're not given the other relative abundance, but there are only 2 isotopes. So the other isotope, the relative abundance, should be 100 minus 92.58. So that's what we're going to use. Okay, so I worked it all out, and I got my weighted averages. I got my weighted average of 6.941. And wow, it matches the periodic table just perfectly. So anyway, I hope running through these 3 has been helpful. I'll make another video just in case you feel like you need more. Actually, the next video will include some maybe a little bit more complex problems.